In this video, we're going to learn inequalities in two triangles and indirect proof. For now, I don't want you to focus on this vocabulary just yet. Instead, I want you to read through the Hinge Theorem, and I'll walk you through it. The Hinge Theorem states that if two sides of one triangle are congruent to two sides of another triangle, so look to the right, meaning Vx and RT is congruent, VW and RS is congruent. And then here is the important part. The included angle of the first triangle is larger than the included angle of the second. So I highlighted in green, the green angle in the inside, WVX is 88 degrees, and SRT, the red angle, is 35 degrees. Then the conclusion we draw is the third side, which is WX, must be longer than the third side, ST. Okay, so again, if two sides are congruent, but if the included angle is greater, then the opposing side in the triangle is greater than its corresponding side in the second triangle. The converse of it is also true. If two sides of one triangle is congruent and the third side, so now we're only talking about side, the third side of the first triangle is longer than the third side of the second triangle, then the included angle in our case here is C is greater than the included angle of the second, which is F. See, F is facing 9 and C is facing 12. Okay, so again, the theorem states that if two sides are congruent but the included angle in one triangle is greater, then the side facing that angle is larger than the third side in the second triangle. The converse of that states if two sides are congruent and the third side is larger in one triangle, then that corresponding angle opposing the third side is larger than that in the second triangle. Okay? Let's see how we use the Hinge theorem and the converse of it. Given that AD and BC are congruent, and that's marked by these two markers here, and how does angle 1 compare to angle 2? Angle 2 is right here. Okay? So we know that it's given that AD and BC is congruent. It's also true that DB is congruent to itself, reflexive property, right? And now we've got two sides congruent, but we know the third side, 34, is greater than 33. So AB is greater than DC. Because of that, by the converse of the Hinge theorem, the angle facing AB, the side that measures 34, is angle 1, and the measure of the angle must be, whoops, I made a typo here, here's 33. That measure of angle 1 must be slightly greater than the angle measure of angle 2. So this is our converse of the Hinge theorem. Okay, so that's how we use it. Here's another example in word problem. Car A leaves the mall. Notice that the mall is right here. So car A leaves the mall, heads due north, so heads this way for 5 miles, and then due west for 3 miles. So heads this way for 3 miles and arrives at this point. Okay, and car B leaves the same mall, good, and now it's heading due south also for 5 miles, but then turns 80 degrees. Be careful if you're not a driver yet. Understand that 80 degrees go from this point, let me use red, from this point to that point. That's the outside angle of 90 degrees. Same thing here, the 90, it turns due west, which means it made it 90 degrees. It's really to go from toward, if you have your pencil, you should draw from left to right. But because it's 90 degrees there, it's 90 degrees inside that triangle as well. So this time it turned 80, car B turned 80 degrees and then traveled 3 miles to right here, point B. Let me give it a dot right there. Now, which car is further from the mall? In other words, it's asking us about these two distances between car A to the mall and car B to the mall. Let's see how we do this. So we know that, let's give it some reference point. If it's the mall here, I'm going to call point M, which is right here. And this point I'm going to call C, and this point I'm going to call D. Okay? So we know that I just drew this diagram, and as you notice, there are 2 triangles there. We know that the length of MC equals that of MD. They're both 5 miles, right? So they're congruent. And then we also know that DB at the bottom is congruent to, it's the same length of what's that? Is that AC on top? It's 3 miles, right? So, but look at this angle here. We've got this angle, vertical angle here. So angle that is AMC is congruent to angle BMD because they're vertical angles by vertical angle theorem. They're congruent. And we also know that if I already pointed out that the angle measure for ACM is 90 degrees. And we know that we can calculate the angle measure of BDM. Notice the exterior angle of BDM is 80 degrees. So 180 minus 80, I would have 100 degrees right here. That's 100 degrees because together they make a straight line. In this case, because angle measure BDM is greater than angle measure ACM, we can draw the conclusion that the sides that they face, which is MB, would be greater than MA. Therefore, and that's by the Hinge theorem. And therefore, to answer this question, which car is further? Car B is further from the mall. Okay, so those are 2 examples of how we use the Hinge theorem and the converse of the Hinge theorem. Now let's go back and look at indirect proof. It's very, very wordy, but it's actually a very simple complex. It's a very simple concept. And kids, frankly, do it all the time. So let's read through this and try to understand it first. And indirect proof uses a temporary assumption that the desired conclusion is false, by then showing that this assumption leads to logical impossibility. The original statement is proven true by contradiction. So exactly what it is saying. So it's basically asking you to prove if A equals B. Since you don't have enough information to prove A is equal to B, then you can assume A doesn't equal to B. And then A doesn't equal to B leads to some bizarre statement that everybody knows is untrue. Then the opposite, by contradiction, A equals B must be true. So, and here are the steps that helps you walk you through it. So let's look at an example here. So to prove this, we're going to temporarily assume X is divisible. by 6. And that means that x divided by 6 equals an n, and n belongs to natural number. N is an element of a natural number. Remember, natural numbers are what babies use. When we start counting as babies, we always say 1, 2, 3, 4, and we get excited when we count to 100. So those are not natural numbers that do not include 0. Babies, for some reason, do not start counting from 0. So that's how I remember what natural numbers are. And if I multiply both sides by 6, I have x equals 6n. So that's the first step. The second step, if x is odd, by definition, x cannot be divided by 2. But look, I can rewrite 6n into 2 times 3n, right? So we know that 3n is a whole number. And so in this case, it just proved that x is an even number that can be divided by 2. This contradicts the given condition that x, given that x is odd. So we're contradicted here. Therefore, our conclusion, therefore the assumption x is divisible by 6 is false. And it proves that x as an odd number is not divisible by 6. Okay, so again, the first step we made an assumption that's opposite of what was given. And then second step, we proved that that based on that assumption, we came out with something that's completely opposite, completely bizarre, completely illogical, and therefore we circle it around, and because of that, we prove the opposite is true, and the opposite was what was given, that odd is x is an odd number and is not divisible by 6. Okay? So I hope this is helpful. We'll see you in class, guys. Bye.